Toyota is the leader in vehicles using internal combustion engines. Yet, due to the environmental impact of fossil fuel-powered vehicles, the Japanese industry titan has decided to stop producing them. For this reason, it has switched to hydrogen, a novel fuel. Toyota has created a brand new hydrogen vehicle that shocks the industry, but many consumers are curious about what the vehicle offers. How does the new hydrogen-powered automobile operate? And what benefits do cars running on hydrogen offer? Nature is full of hydrogen. The most prevalent compound on Earth, water, contains it. Almost all organic compounds, including your body, contain hydrogen, which accounts for around 61% of all the atoms there. Considering this, it is not surprising that someone would consider using hydrogen as a fuel to create energy. So, how does this work if you want to use hydrogen to power a car? There are actually two choices available to you. The hydrogen engine is one, while hydrogen fuel cells are the other. While using the same fuel, both technologies are distinct from one another. In industries like medium and heavy-duty trucking, hydrogen engines are gaining more and more traction. Essentially, these are internal combustion engines that use hydrogen rather than gasoline. This method of utilizing hydrogen has advantages such as being based on current, cutting-edge, and dependable internal combustion engines. It is a technology that automakers are accustomed to using in their development of their vehicles. Similarly, it is a technology that fleet operators are accustomed to using, maintaining, troubleshooting, and servicing. Medium and heavy load applications are considerably more likely to switch to hydrogen fuel cells or hydrogen engines, according to Cummins, an engineering firm involved in hydrogen engines. The business further asserts that it is conceivable that buses and heavy-duty trucks powered by hydrogen will become commonplace in the ensuing decades. Also, it's possible that you'll see more hydrogen engines in ships, construction vehicles, agricultural machines, and off-road vehicles. Due to their use cases and mission characteristics, these are most likely going to be the apps that are challenging to electrify. The use of hydrogen engines to generate power may increase. The hydrogen fuel cell, which Toyota has fully embraced, is the alternative technique to utilizing hydrogen as a fuel. You might be surprised to learn that burning hydrogen is not a component of hydrogen fuel cells. Moreover, an electric vehicle and a hydrogen fuel cell vehicle share many similarities. How then does a hydrogen fuel cell vehicle operate? Initially, sidecars with hydrogen fuel cells function. They are available in different applications. In a hydrogen fuel cell vehicle, an electric motor and other electrical systems are powered by the hydrogen fuel cell unit, which also generates electricity. Hence, you'll discover that a battery electric vehicle and this one share many components. One of the most promising fuel cell technologies is the polymer exchange membrane fuel cell, PMFC. It employs a fuel cell process that is among the most basic ever. There are 4 basic components in a fuel cell. The fuel cell's anode, or negative pole, transmits the hydrogen molecule-freed electrons so that they can be utilized in an external circuit. It has channels carved out of it that evenly distribute the hydrogen gas around the catalyst's surface. Channels etched into the cathode, the fuel cell's positive post, distribute oxygen to the catalyst's surface. Also, it transports the electrons from the external circuit back to the catalyst, where they can combine once more with oxygen and hydrogen ions to make water. The proton exchange membrane is also formed by an electrolyte, much like in a battery. Despite the fact that it may appear to be a typical kitchen plastic wrap, this is a specifically treated material. Although it repels electrons, it conducts positively charged ions. For a PMFC to function correctly and maintain stability, the membrane must be kept moist. A catalyst, a unique substance like oil, is another component of a hydrogen fuel cell that helps the hydrogen and oxygen react. It is often made of extremely thinly coated carbon paper or cloth with platinum nanoparticles. The catalyst is textured and porous to allow the platinum to be exposed to as much hydrogen or oxygen as possible. The polymer exchange membrane is on the catalyst's platinum-coated side. The manufacturer adds a fuel tank where the hydrogen is kept, and an exhaust where the byproduct, water vapor, escapes from when it is used in autos. Nevertheless, why is Toyota creating hydrogen fuel cells? Because water, a harmless byproduct of hydrogen fuel cells, is produced as a byproduct. One reason is the reduction of pollution. The efficiency of fuel cells is likewise quite high. Up to 80% efficiency is possible if the fuel cell is fed with pure hydrogen. This indicates that it transforms 80% of the hydrogen's energy into electrical energy. When electrical energy is transformed into mechanical work by an electric motor and an inverter, we must take into account the energy lost in the process. This is an optimistic estimate, and actual values may differ. Even in the worst-case scenario, hydrogen fuel cells are more efficient than gasoline engines, which can only manage between 30 and 35% in the best-case scenario. Typically, a motor inverter system can be 80% efficient, leaving us with about 60% efficiency for a hydrogen fuel cell car. Toyota first began experimenting with fuel cell vehicles in 1992. The automaker introduced the Mirai, a hydrogen fuel cell automobile, in 2014. Yet, Toyota packed the superior fuel cell system utilized in its Mirai saloon into small fuel cell modules to push its hydrogen expertise from automobiles to more varied applications. In 2022, it intended to begin producing second-generation modules. The new system has been constructed into modules that are smaller, lighter, and offer a higher power density. Due to their availability in two shapes, a cube and a flat rectangular shape, they may be more easily customized and adapted for various uses. Also, it can offer a driving range of more than 500 kilometers, which is more than many battery-powered cars can. A manufacturing team for the Toyota Motor Europe (TME) Research and Development Center in Brussels will be used by Toyota to assemble the second-generation fuel cell modules. The new facility has a pilot assembly line that combines cutting-edge technology with top-notch assembly methods. Toyota has contributed to the creation of larger hydrogen fuel cell vehicles aside from the Mirai. They include the Sora bus and heavy-duty vehicle prototypes. Do you recall the prior discussion about the hydrogen engine? Toyota is also heavily invested in that. It revealed it was building a hydrogen engine last year. It mounted the engine on a racing car modeled after the Toyota Corolla Sport that it intended to compete in motorsport events. Using fuel delivery and injection technologies modified from those used with Toyota's gasoline engines, the vehicle's engine produces power through the combustion of hydrogen. As a result, during racing, the high-performance automobile emits no CO2. The car benefits from hydrogen being burned more quickly than in gasoline engines, which gives it a trait of good responsiveness. It also has the benefit of generating all the thrilling noises and vibrations that fans of auto racing like hearing and experiencing. Making the engine or fuel stack is one component of hydrogen fuel cells, and manufacturing the hydrogen to fuel it is the other. The second component is as crucial because the car cannot function without it. Toyota is therefore heavily involved in developing the infrastructure for the supply of hydrogen. The ultimate goal is to have hydrogen filling stations where you can pull in and pump hydrogen into your tank, similar to petrol stations. For instance, Toyota made plans to use hydrogen produced in the Fukushima Hydrogen Energy Research Area in Namitown, Fukushima Prefecture, to fuel the hydrogen-powered race car. But Toyota needs to considerably extend this hydrogen supply infrastructure if it wants hydrogen cars to be acceptable on a global scale. The difficulty is in producing enough hydrogen to run the world's fleet of hydrogen-powered vehicles. Hydrogen is abundant in nature, yet it is difficult to extract. As most of the world's supply originates from non-renewable sources, hydrogen is actually a contentious energy source. But Toyota has a creative method for creating hydrogen from cow manure, meaning that both your food and your auto fuel will originate from these four-legged beasts. Toyota revealed the Trigen project as a result at the Los Angeles Car Show. The facility will use methane gas extracted from dairy cattle manure to make hydrogen, making the operation the first of its kind in the world. The power plant will produce hydrogen, water, and electricity. The Toyota plant's hydrogen will power further Toyota Mirais as well as trucks made using Toyota's Project Portal. When the project is completely operational, 2.35 megawatts of power and 1.2 tons of hydrogen per day will be produced. Toyota is collaborating with the fuel cell energy firm. The business has been working on creating its own natural gas-to-water, hydrogen, and carbon dioxide separation power facilities.